Hello again. I just got done implementing the little ray tracer using OpenCL. Um, it took It took at least 2 weeks to kind of get it done because I've never really used OpenCL before, and let's just say it was pretty much a learning experience. I guess let's dive into this. OpenCL, what it is a compute kind of language API where it allows you to do like generalized stuff using the video card itself, which is pretty awesome. Um, it came out a few years ago. This is the first real kind of time I've ever played with it. I don't know why I haven't played with it in the past, but now I officially know how to do OpenCL coding, which is awesome. Um, for this example, the I'm only using two libraries for it, which is SDL and OpenCL. Um, I'm not using OpenGL period because I don't. It could be OpenGL causing issues from the previous one. Um, a person who was playing around with it, his machine had an NVIDIA card and it did some pretty strange things, to say the least. So I decided to try this with OpenCL instead, see if it will work or not. Hopefully, this example will work on both AMD cards and NVIDIA cards. I do apologize for that. So let's look at the code real quick. For starters, OpenCL has its own built-in types. I had to do some REST conversions between GLM's math library and OpenCL. So that's a thing. Um, OpenCL itself is pretty straightforward. It's very kind of a straightforward API. It does not have a lot of bells and whistles like OpenGL has. It's pretty simple to get set up, but at the same time, there are some limitations. For one, let's say if you're doing using buffers, you have to recreate the buffer again in order to update said buffer, which is kind of a problem that you might face if you ever use this API. Um, the other cool thing about this API is that if you can have multiple kernels, which is kind of an entry point to a OpenCL program. Um, you can have multiple ones in one program, which is pretty sick. I wish GLOSL and like HLSL had this feature, which is it's really cool. Um, because I'm not using OpenGL, I have to make my own frame buffer for this. And if we go down here, I'll show you how it works. Pretty much when you're rendering the scene, the first method you're going to call in this particular demo is this one, which is render. It does all the ray tracing stuff, and all the color data gets recorded to a software frame buffer. And then after that's done, I simply copy everything over to the SDO um, screen surface, and it gets presented, which is pretty straightforward and pretty awesome. That means that I don't have to rely on like what anything OpenGL is doing. I can make my own custom kind of color format, which here I'm just using floats, and then I do some REST conversions to whatever SDL supports. So that's really cool. It's pretty much the same thing. One limitation of OpenCL is that I don't know if you're going to support uniform variables. So you have to pass things to whatever kernel you're using, which is kind of a limitation. So your function arguments are going to be longer, but that's fine. It's not a big deal to me. The other cool thing, because of how general OpenCL is, you can do things with just buffers. I haven't tested images yet, which when I start making like more advanced kind of demos, I'm gonna probably be using images instead of just buffers for this purpose. Alright, as you see, it's pretty much the same code. I did improve the speed of it a little bit. Instead of doing like 3 kind of reflections, I'm only doing 1, or actually 2 for right now. I can easily add in a 3rd one, and it should work pretty nicely. How to initialize OpenCL is pretty straightforward. You have to basically query for the platform, and then you get the devices for it, and you look for one that's kind of like a GPU type to get this working. This can also work on a CPU. I would highly advise against it because CPUs are not really well suited for ray tracing. And I'm also using the 1.2 version of it, so it will run in NVIDIA cards. After you get that shenanigans done, you create a context, then you get the command queue, then you open up this program right here, and then you grab the kernel data, and you set up buffers that you will be using. Okay, let's get this kind of running real quick, and I'll show it to you real quick. It's essentially the same demo. It runs a lot faster actually, which is pretty awesome. As you can see, it runs smoother than the compute shader example. There's like no slowdown whatsoever. Because I'm not doing the 3 kind of recursive reflections. If you look at the bottom here, the reflections are not perfect, but that's fine. I can live with it. I'm just happy it's working. And yeah, I already have it uploaded on my GitHub account if you want to take a look at it. And I think this is it for this particular scene. The next stuff I'm going to be working on is adding more kind of objects that you can render, because just doing sphere rendering is kind of boring. I want to add in cubes, planes, possibly donuts, which would be pretty awesome. And yeah, this is kind of it for this little update, and I'll see you all next time. And hopefully this one will work with NVIDIA cards. Well, y'all take care and have a good day.